Kia ora and welcome to this video on question 5 of the 2010 Scholl Calc exam. This is a personal favourite of mine. I think any exam that references the comic strip or the webcomic XKCD is doing a pretty good job. So it's all about the dating pool and how the dating pool is growing over time up to a certain point. But the first part of the comic here talks about the dateable age range, so we need an expression for that. The question says here, find a rule for the width of the dateable range. So that's our first part to do, using the standard creepiness rule of don't date anyone under the age, or half your age plus 7 rule. Then we've got to integrate the function for the singles, the proportion of people that are single, which is decreasing over time. So we integrate that to find some sort of measure of the dating pool. And then the question, part C there, is asking us to find the largest, or find the age at which the dating pool is at the largest. Okay, so let's get stuck in. The first thing you can do to get your head around part A is to make a little table. And it's kind of given to us as a hint in the comic itself, when it uses a range of 16 to 22 for an 18-year-old. So for example, if I said T being the age in years of a certain person, and I said that was 18, then we've got the rule don't date under half your age plus 7. So the lower limit for that are half your age plus 7. Half of 18 is 9, 9 plus 7 is 16. But there's also an upper value that we need to find. The question says to find an expression for this. And the upper value will be the value of which, if you apply the half your age plus 7 rule to that, you won't get lower than 18. So 18 will be the lower limit for someone that is at a higher value, the upper value we're trying to find. So what we do is do the half your age plus 7 and equate that to 18, because someone else is going to have a lower limit. And if we solve that problem, 18 minus 7, 11, 11 times 2 is 22, that gives us our upper age for an 18-year-old, that they can't date over 22. And if we did the same thing for, say, the next part of the comic talks about a 30-year-old, so if we do 30 there, the lower limit, half your age plus 7, so half of 30 is 15, 15 plus 7 is 22, and half your age plus 7 equals to 30, 30 minus 7 is 23, 23 times 2 is, okay, so that's the upper limit for this person. Okay, so we're finding an expression for this upper value in terms of age t. So all I need to do is replace this formula that I've been using both times and make the age there the upper limit. So u over 2 plus 7 equals to t. Rearrange that by going t minus 7 multiplied by 2. And that there's our upper limit. And then the width of the range, or the width of the range of, or the dateable range I think they're referring to in the question, yep, dateable range, is going to be just the difference between the upper limit and the lower limit. And the lower limit there is half your age plus 7. So if we tidy that up a little bit, got 2t minus a half t, 3t over 2, and then minus 14, minus another 7, minus 21. Okay, so the width increases over time. It's a linear function, and as t gets larger, as your age gets larger, the width is increasing, because the age range of allowable ages to date increases according to the rule. Okay, second part, integrate the s of t function which is the proportion of singles at some age t, integrate it between the lower and upper limits to find a measure of the dating pool. So what we're doing here, it's kind of in the graph, we've got the proportion of singles is decreasing over time. We're only applying this rule for t greater than or equal to 18. I think that's just to ensure that this question isn't a creepy question. After all, it's in an exam written by NZQA, and we've got this lower limit and an upper limit, at which and that range increases over time, and we're trying to find the area here, which is kind of a measure of how many singles are on offer to a person of age t. And that's going to increase over time to a point, and then it's going to drop off. The range keeps increasing, but the proportion of singles drops, so the dating pool will eventually start decreasing again as there are not many people on offer anymore. Okay, so we're integrating the function s of t is e to the minus 0.05t. Pretty simple function, and we're integrating it between a lower limit of half your age plus 7 and an upper limit of 2t. What was it? 2t minus 14, I believe. Yep, 2t minus 14. Okay, so pretty simple integration here. And let's call this m for some measure. Okay, e to the minus 0.05t divided by negative 0.05 between 2t minus 14 and t over 2 plus 7. Substituting in, we're dividing there by 1/20th, so we can times by minus 20. E to the negative 0.05, actually I'll factor the minus 20 out, negative 0.05 times 2t minus 14 minus e to the minus 0.05 t over 2 plus 7. Okay, that's our measure. And then part C asks us to find the age at which the dating pool is the largest. So in other words, this measure is the biggest possible. And one thing to note is we integrated in part B, we integrated with respect to little t, which is a variable in terms of age. And now when we differentiate this thing to find its maximum, we're differentiating with respect to capital T, a different variable. In other words, we can't just reverse the process that we've just done. We can't just differentiate and get back to e to the minus 0.05t. Okay, so last part, we want dm dt. The minus 20 will just sit out the front. We get e to the negative 0.05 2t minus 14 multiplied by the derivative of the power, because we're using the chain rule, and remember that this whole thing here differentiates to itself multiplied by the derivative of the power. The derivative of the power, it's a linear function, is minus 0.01. No, just minus 0.1. And then the second term differentiates to itself as well. Multiplied by the derivative of that power, which is minus 0.025. Okay, we need to make that equal to 0. We told in the question we don't have to prove it's a maximum. To make that equal 0, the thing in the brackets must be 0. So we've got minus 0.1 e to the negative 0.05 times 2t minus 14 equals to minus 0.025 e to the minus 0.05 t over 2 plus 7. You might be thinking, what have I done with that minus? But I've made the whole bracket equal to 0, which means that the first part of the bracket is equal to the second part of the bracket. And the minus, you can think of it as moved on to the other side of the equation. Okay, now we need to solve this. convention with these equations is to divide the constants down one side, so I could go and write that on the left hand side, and then put the exponential terms to the other side. Well, what happened there? How did that end up like that? That's silly me. And then divide by the other exponential term. What am I doing? Right, move the number in the front down the bottom left. So let the exponential term stays there. I'll take the other exponential term from the left hand side. And to solve this I need logs, but the first thing I can do is use the rules of powers. You know, the base there is the same. Both of the terms have base e, which means I can subtract the powers. And because the power at the bottom is a negative, I've actually got a plus there. Okay, log both sides. That will get rid of the e on the right hand side of the equation, and then we're going to have to work with some like terms here to tidy up and solve for t. The left hand side becomes 1.3863 to 4 decimal places. The right hand side becomes 0.075t minus 1.05. Solve that linear equation and you get t equals 32.48 years. Which is quite ironic because as I record this I'm 32.2 years old. So it's almost almost at the peak dating pool for me. Anyways, we'll catch you next week for the 2009 paper. I hope all your prep is going well for the Skull Calc exam.